Imagine standing on a beach, staring at an endless ocean that stretches beyond the horizon in every direction. No landmarks, no GPS, no compass. Now imagine deciding to sail into that void, knowing that the nearest land might be 1,000 miles away, a tiny speck of earth smaller than a city block, hidden somewhere in 25 million square kilometers of open water. Most of us would call that madness. The Polynesians called it Tuesday. For centuries, these master seafarers accomplished what seemed utterly impossible. They discovered and settled every habitable island scattered across the Pacific Ocean, from Hawaii in the north to New Zealand in the south, from the Philippines in the west to Easter Island in the east. They did this without any of the tools we consider essential for navigation. No magnetic compasses, no sextants, no charts, nothing written down at all. When European explorers first encountered Polynesian cultures, they refused to believe these people had navigated the Pacific intentionally. The prevailing theory was that they'd simply drifted on currents, stumbling onto islands by pure luck. That racist assumption persisted for generations, but the truth was far more extraordinary. The Polynesians had developed a sophisticated navigation system so advanced, so precise, that modern scientists are still studying it today, trying to understand how they achieved the impossible. What you're about to discover will change how you see the ocean, the stars, and human capability itself. The Polynesian Triangle is one of the largest cultural regions on Earth. Draw a line from Hawaii to New Zealand, another from New Zealand to Easter Island, then back to Hawaii. Inside that triangle sits an area larger than Russia, filled mostly with water. Yet somehow, between 1500 BCE and 1300 CE, Polynesian voyagers found virtually every island worth finding within this vast expanse. Let that sink in for a moment. Easter Island is one of the most isolated places on the planet. The nearest inhabited land is over 1,000 miles away. It's a piece of volcanic rock, barely 15 miles across. Finding it in the Pacific is like finding a specific grain of sand on a beach while blindfolded. Yet the Polynesians not only found it, they settled it, bringing with them plants, animals, and everything needed to build a thriving civilization. When Captain James Cook sailed the Pacific in the 1772, he was astounded. He met Polynesian navigators who casually described islands hundreds of miles away, islands Cook himself hadn't yet discovered. These navigators drew him maps from memory, accurate maps showing distances and positions that matched his own careful measurements made with the finest European instruments. Cook wrote in his journals that these people possessed a navigation system that rivaled anything Europe had developed. But back in European universities, scholars couldn't accept this. The prevailing scientific racism of the era insisted that such sophistication was impossible for Pacific Islanders. In 1947, Norwegian explorer Thor Heyerdahl sailed a primitive raft called Kon-Tiki from South America to Polynesia, trying to prove that South Americans had settled the Pacific, not Polynesians navigating from Asia. He argued that Polynesians couldn't possibly have sailed against the prevailing winds and currents. His theory was absurd, easily disproven by linguistics, genetics, and archaeology. Yet it captured the public imagination because it fit the narrative people wanted to believe. The real story, the true story of Polynesian navigation, remained buried under layers of colonial prejudice and academic skepticism. But here's what those skeptics missed. The Polynesians weren't lucky. They weren't drifting. They had mastered a science that European sailors couldn't even comprehend. At night, when the sun disappeared and the ocean turned black, Polynesian navigators looked up and saw a map written in light. The stars were their primary navigation tool, but not in the way you might think. They didn't use instruments to measure angles or calculate latitude. Instead, they memorized the entire sky. They knew every star, every constellation, and exactly where each one would rise and set at different times of the year from different locations in the Pacific. They organized the heavens into what they called star houses or star compasses. Imagine the horizon divided into specific segments. Each segment had stars that would rise from it or set into it. By watching which stars appeared on the horizon and when, a navigator could determine direction with remarkable precision. If you were sailing from Tahiti to Hawaii, you'd know that Arcturus, which they called Hokulea, would pass directly over Hawaii. You'd aim your canoe so that Hokulea stayed in a specific position relative to your vessel throughout the night. During the day, the sun served the same purpose. A trained navigator knew the sun's path across the sky for every season, every latitude. They could tell you their direction based on where the sun rose, where it sat at noon, and where it set. The angle of sunlight on the water, the way shadows fell across the canoe, all of this was data to be read and interpreted. But here's where it gets truly remarkable. This knowledge wasn't written down. Not a single star chart existed. Everything was memorized and passed down through oral tradition. From master navigator to apprentice, young students would spend years, sometimes decades, learning to read the sky. They'd practice on land first, lying on special platforms built to simulate the deck of a moving canoe, watching the stars wheel overhead, night after night, until the celestial map was burned into their memory. These navigators held a sacred position in Polynesian society. They were priests of the ocean, keepers of knowledge that could mean life or death for entire communities. A single mistake, one miscalculated star bearing, could send a canoe and its crew into empty ocean, sailing until their food and water ran out. The pressure was immense, the responsibility absolute. The training was rigorous beyond anything we'd recognize today. Apprentices learned not just star positions, but also the stories and songs associated with each constellation. These weren't just memory aids, they were a complete cosmology, a way of understanding the relationship between sky, sea, and land. The night sky wasn't a random scattering of lights. It was a roadmap, a calendar, a clock, and a compass all woven together. But even the stars had limitations. Clouds could obscure them for days. Storms could throw a canoe off course. And during the day, when only the sun was visible, navigators needed other tools to maintain their bearing and find their way. While European sailors saw the ocean as a barrier, Polynesians saw it as a highway marked with invisible signs. They could read the water itself. Waves became their guidebook. Not just surface waves, the ones you can see breaking and churning, but deep ocean swells. These swells are different. They're generated by distant storms or consistent wind patterns, and they travel across thousands of miles of open ocean, maintaining their direction and rhythm. A skilled navigator could detect multiple swells moving through the same water, each from a different source, each telling a story about what lay beyond the horizon. Here's where it gets fascinating. When a deep ocean swell encounters an island, it doesn't just stop. The wave energy wraps around the island, bends, reflects, and creates distinct patterns in the water that extend far beyond the island itself. An experienced navigator could detect these patterns from 30 miles away, sometimes more. They'd feel changes in the wave rhythm, notice subtle differences in how swells interacted, and know with certainty that land was near, even when nothing was visible on the horizon. In the Marshall Islands, navigators created stick charts, intricate frameworks made from coconut ribs lashed together with coconut fiber. Shells tied to the framework represented islands. The bent sticks represented wave patterns, showing how swells curved and refracted around each island. These charts weren't meant for use at sea. They were teaching tools, three-dimensional textbooks helping apprentices visualize and memorize the invisible wave patterns they'd need to recognize on actual voyages. Polynesians didn't just observe waves, they felt them. Navigators would lie in the bottom of the canoe, pressing their bodies against the hull, sensing the rhythm and roll of different swells through the wood. They could distinguish between wind waves, ground swells, refracted waves, and reflected waves, all simultaneously. It was a physical, almost meditative practice requiring absolute concentration and years of experience to master. They'd also trail their hands in the water, feeling for temperature changes and current shifts. Ocean currents, while invisible, follow predictable patterns: warm currents and cold currents, each with distinct temperatures and speeds, and a navigator who knew these patterns could use them for orientation just as surely as a star bearing. The surface of the ocean told stories too. Smooth patches indicated protected water behind an island. Choppy sections revealed where different currents collided. The color of the water changed depending on depth, revealing underwater reefs and seamounts long before they became hazards. Floating seaweed, driftwood, and other debris accumulated along current boundaries, creating visible lines that could be followed like roads. Everything was information. Everything was data. The ocean was an empty space. It was alive with signals waiting to be interpreted. But waves and currents alone couldn't reveal the location of distant islands. For that, Polynesians relied on messengers from the land itself. Birds became the Polynesians' most reliable GPS system, living compasses that pointed toward land with unerring accuracy. Certain bird species never stray far from shore. Terns, for example, fly out to feed during the day, but always return to land at night. A navigator who spotted terns in the morning knew they'd flown from an island. Watch which direction they came from, and you'd know where land waited. Spot those same birds flying back in the evening, and you'd have confirmation. Follow their flight path, and you'd find your destination. Frigate birds, with their distinctive forked tails and massive wingspans, could range farther from land than terns, but they still needed to roost on islands. Spotting frigate birds meant land within 100 miles, sometimes less. Petrels and other seabirds had their own ranges, their own behaviors. A master navigator knew them all, knew what each species indicated about distance and direction, but it went deeper than simple observation. Polynesians understood bird migration patterns, feeding behaviors, even the subtle differences in flight styles that indicated whether a bird was heading out to hunt or returning home. They'd watch how birds responded to weather, using them as early warning systems for approaching storms. Flocks of birds diving and feeding revealed schools of fish, which themselves followed currents and temperature gradients that could aid navigation. The ocean's color told its own story. Deep blue meant open water, thousands of feet deep. Lighter blue or green indicated shallower water, suggesting an island or reef nearby. Muddy or brown water meant river runoff, a sure sign of a large landmass. Polynesians trained their eyes to catch these subtle color shifts long before land came into view. Floating vegetation provided clues too. Certain plants only grew on specific islands. Spot those plants floating in the current, and you'd know which island was upstream. Fresh leaves and branches meant land was close. Old, waterlogged debris could still indicate direction, but suggested greater distance. Then there were the clouds. Islands, especially high volcanic islands, create their own weather systems. Warm land heats the air, causing it to rise. Moisture condenses as it climbs, forming stationary clouds that hover over an island even when the sky elsewhere remains clear. These clouds, visible from 50 miles or more, acted like signposts. Navigators called them the clouds that stood still. Even smell played a role. Land has a distinct odor, a combination of vegetation, earth, and life that's completely absent over open ocean. On days when the wind blew from the right direction, a sensitive nose could detect land before any visual cues appeared. The scent of flowers, the mustiness of jungle vegetation, even the smell of smoke from fires, all of these could travel miles across the water, announcing an island's presence to those who knew how to read the air. Every sense became a navigation tool, every observation added to the mental map, being constantly updated and refined. But all of this, the stars, the waves, the birds, the clouds, meant nothing without one crucial element. Here's perhaps the most staggering aspect of Polynesian navigation. They kept all of this information in their heads. No charts, no logs, no written records of any kind. Every route between every island, every star bearing, every wave pattern, every bird behavior, all of it was memorized. A master navigator carried in his mind what would fill volumes of navigation manuals in any other seafaring culture. The training for this began in childhood and could take 30 years or more to complete. Apprentices learned through repetition, observation, and practice. They'd make short voyages first, island hopping between close neighbors where mistakes weren't fatal. Gradually, as they proved their skills and absorbed more knowledge, they'd be allowed on longer voyages, always under the watchful eye of a master. Songs and chants served as mnemonic devices, encoding complex navigational information in rhythm and verse. A song might describe the star path from one island to another, the sequence of constellations to follow, the wave patterns to expect, the birds you'd see along the way. These songs were more than poetry. They were textbooks set to music, designed to be remembered perfectly and passed down unchanged through generations. The mental maps Polynesians created were three-dimensional and dynamic. They didn't just memorize that Island A was north of Island B. They knew the entire journey. They could tell you what stars would be visible on the first night, how the wave patterns would change on the second day, where you'd start seeing land birds on the third morning. They knew alternate routes in case weather forced them off course. They knew where to find currents that would speed their journey or where to avoid ones that would slow them down. For decades, Western scholars debated whether these voyages were intentional or accidental. Maybe Polynesians just drifted on currents and got lucky, stumbling onto new islands by chance. This debate finally ended when researchers looked at what the Polynesians had brought with them. Archaeological evidence shows they carried breadfruit, taro, coconuts, pigs, chickens, and dogs to virtually every island they settled. These weren't items you'd have on a fishing canoe that accidentally drifted off course. These were carefully planned colonization missions, requiring deliberate voyages with the intention of return or permanent settlement. Modern DNA analysis has confirmed this. The genetic trail of Polynesian expansion can be traced island by island, showing a deliberate eastward movement over thousands of years. The plants and animals they introduced left their own genetic signatures, revealing the routes taken and even the approximate dates of first contact with each new island. The Polynesians knew exactly where they were going. They'd send out exploration missions to find new islands, then return home to report their discoveries. Later expeditions would set out with colonists and supplies, following the routes described by the explorers. This wasn't random chance. It was systematic, organized, and executed with precision that wouldn't be matched by European navigators for centuries. But then, something changed. The great age of Polynesian exploration came to an end. Around 1300 CE, long-distance voyaging across the Pacific essentially stopped. The reasons remain debated, but the consequences were clear. The navigation knowledge that had connected Polynesian cultures across an ocean slowly began to fade. Climate change may have played a role. The medieval warm period ended around this time, replaced by cooler conditions that altered wind patterns and made long voyages more difficult. Resources on some islands became depleted, leaving less surplus for large expedition crews. Inter-island warfare increased, making the cooperative efforts needed for major voyages less feasible. Whatever the cause, the great canoes were beached, and the star paths between distant islands were traveled less frequently than not at all. When Europeans began colonizing the Pacific in the 18th and 19th centuries, they brought devastating changes. Missionaries and colonial administrators actively suppressed traditional practices, viewing them as primitive and pagan. Navigation schools closed. The oral traditions that preserved celestial knowledge were interrupted. Old navigators died without training replacements. By the mid-20th century, traditional navigation had almost vanished entirely. On the tiny island of Satawal in Micronesia, one of the last master navigators remained. His name was Mau Piailug, and he carried in his mind knowledge that was rapidly disappearing from the world. Mau had trained under his grandfather, learning the ancient ways when few others still bothered. He could navigate by stars, swells, and birds. He knew the old songs and could recite the star paths between dozens of islands. He was a living library, perhaps the last of his kind. In the early 1972, a group of Hawaiians became interested in reviving their ancestors' navigation traditions. They built a traditional double-hulled voyaging canoe, naming it Hokulea after the Hawaiian name for Arcturus, the star that passes over Hawaii. But they had a problem. No one in Hawaii remembered how to navigate the ancient way. They needed a teacher. They found Mau Piailug. In 1976, Mau agreed to navigate Hokulea from Hawaii to Tahiti, a distance of over 2,400 miles across open ocean, using only traditional methods, no compass, no instruments, just stars, waves, and centuries-old knowledge. The voyage was controversial. Critics predicted disaster. How could these ancient methods possibly work in the modern age? Surely they'd need to use instruments hidden away for safety. Surely this was a publicity stunt that would end in calling for rescue. 33 days later, Hokulea arrived in Tahiti, exactly where Mau had aimed. He'd navigated with such precision that they made landfall within sight of their intended destination. The voyage was a triumph, proving beyond doubt that Polynesian navigation wasn't primitive luck, but sophisticated science. Mao's success sparked a renaissance. Navigation schools reopened across the Pacific. Young people began learning the old ways again, not from books, but from the few remaining masters who still remembered. Hokulea made more voyages, eventually sailing around the world. Other voyaging canoes were built and launched. The knowledge that had nearly vanished was being resurrected, saved just in time. Mao Piailug trained a new generation of navigators before his death in 2010. His most famous student, Nainoa Thompson, became the first Hawaiian in centuries to learn traditional navigation and later trained others himself. The chain of knowledge, nearly broken, was being reforged. Today, hundreds of students across the Pacific are learning to read the stars and waves, ensuring this extraordinary heritage survives for future generations. What nearly died with Mao and the handful of other traditional navigators wasn't just a navigation technique, it was an entire way of seeing and understanding the world. Polynesian navigation reveals something profound about human capability. With patience, observation, and dedication, people can accomplish what seems impossible. They can cross oceans without technology. They can thrive in some of Earth's most isolated places. They can develop sciences that rival any created before or since. But there's something deeper here. Polynesian navigators didn't conquer the ocean. They developed a relationship with it. They learned its moods, its rhythms, its language. They didn't impose their will on the water. They worked with it, adapting their methods to what the ocean was willing to teach them. The ocean became their partner, not their enemy. This philosophy contrasts sharply with how modern navigation works. We use technology to brute force our way across the ocean, relying on satellites and electronics to tell us where we are. If those systems fail, we're helpless. Polynesian navigators would have found this dependence on tools both baffling and dangerous. What happens when your tools break? When your batteries die? When your GPS satellites malfunction? Modern science is rediscovering wisdom in these ancient methods. Climate scientists study how Polynesians predicted weather patterns without instruments. Marine biologists learn from traditional knowledge about fish behavior and ocean ecology. Sustainability experts examine how Polynesians managed resources across vast distances without destroying their environment. Cognitive scientists study how the human brain can store and process such massive amounts of spatial and temporal information without writing anything down. Across the Pacific today, navigation schools teach traditional methods alongside modern ones. Students learn to use both sextants and star compasses, GPS and wave patterns. The goal isn't to reject technology, but to preserve options, to maintain skills that don't depend on batteries or satellites. In a world increasingly aware of how fragile our technological systems are, this redundancy has practical value. But perhaps the most important lesson is philosophical. Polynesian navigation required paying attention. It demanded that navigators slow down, observe carefully, notice subtle details that others would miss. They had to understand context, how different environmental factors interacted and influenced each other. They had to think systemically, seeing the ocean not as empty space, but as a complex, interconnected web of patterns and processes. We've lost much of that capacity in our modern rush. We want instant answers, immediate results. We trust our devices to do the observing for us, while we stare at screens and ignore the world around us. Polynesian navigators would have found this incomprehensible. How can you navigate if you're not paying attention? How can you understand the ocean if you're not experiencing it directly? Their methods remind us that human intelligence isn't just about storing facts or calculating numbers. It's about perception, pattern recognition, and the wisdom that comes from deep observation over long periods. It's about knowing something so thoroughly that you can sense it, feel it, predict it without conscious thought. That kind of knowledge can't be downloaded or looked up. It has to be earned through years of patient practice. The Polynesians navigated thousands of miles across the largest ocean on Earth using stars that revealed direction, waves that announced islands, birds that pointed toward land, and mental maps that held more information than most libraries. They did this not once by accident, but repeatedly, deliberately, with precision that astounded everyone who witnessed it. Their achievement stands as one of humanity's greatest accomplishments, a testament to what people can do when they pay attention, when they work with nature instead of against it, when they dedicate themselves to mastering a craft completely.